All right, ladies and gentlemen, you asked for it. Now here it is. We're going to go through this Chapter 7 take-home quiz. Now, just for starters, remember, the take-home quiz means nothing, okay? It's just a name. Don't get hung up on it. This version of the video is going to be all calculator-based, and then I will come back and we'll talk about some of the parts that I did, if you'll excuse me, algebraically as well. But these first two problems, they're calculator all the way, okay? It gives this big long use log base 5 of 2 and log base 5 of 3. They want you to do a bunch of math to then estimate these, but the calculator can estimate it for you just as fast using the change of base formula. So for these two problems, you come to the calculator, get out of that menu, and you're just going to use change of base. Now remember, change of base is log of the big number, log of the argument, divided by log of the base. So log 24 divided by log of 5. And that comes out to 1.9746, and that is the answer. And that's all you need. 4 decimal places, nearest 10,000th, 1.9746. Okay? Take a minute, pause the video, try the next one, and then I'll do it. Same process. I'm even going to get tricky. You can do log parentheses 5 divided by 4. Okay, so log of 5/4 divided by log of 5. And there's your answer. Now, when I say I was going to get tricky, I wanted to show you that you can even use natural log and get the exact same result. Okay, exact same result. So it doesn't even matter if you use common log or natural log, as long as you have a different base than what you started off with, you're in good shape. So, yeah, this comes out to 0.1386, and you're good on the first two, okay? So, that's these two problems. Now, you'll notice I'm only doing the back page. We'll talk about the front page in class, but this is the one we had the most trouble with, so I want to focus on these problems. This really poorly printed black gray stripy box was basically trying to explain step by step how to use the calculator. I'm going to walk you through that here. And again, can we do these algebraically? Yes, we can. They're kind of a pain a lot, even with my skills, so we're not going to really beat that one too hard unless you want to watch the algebra video, at which point, please go watch that and enrich yourselves. But for the calculator portion, we're going to graph the left side, which is log of x minus 3 divided by log of 7. And that is just the change of base formula, log of the big number divided by log of the small number, okay? Log of the argument divided by log of the base. We're just rewriting this using a log base 10. Minus log x minus 6 divided by log of 7. Okay, same thing. Press enter, and then we now have the left side entered in, and now we have to type in the right side, which is just going to be log of 6 divided by log of 7. Which you might notice there's no x in there, which means this is actually just going to be a horizontal line because this is just going to come out as a number, okay? Log of 6 over log of 7, that's a number. It's going to be an ugly decimal, but it's just a number. So when I graph that, it's just going to be a horizontal line. That's a constant function. And we're going to see where this horizontal line crosses this logarithmic curve, okay? So we press graph, and with any luck, they'll cross on screen, which it looks like they do. Give it a second. Right there, we can see it. Okay, so our intersection happens right there. So to find that intersection, second calc and option 5 for intersect. Okay, now here's where this gets tricky because it starts off at x equals 0, but at x equals 0, the logarithmic function is not defined. It's going to have an asymptote somewhere over here. It looks like 6 or 7. So we have to move this cursor over until it shows up. 3, 4, 5, 6. Yeah, right around there. That was pretty good. Yeah, right there around, 6.3, 6.5. I just have to have somewhere on the first curve that's actually in the domain, right? I can't pick some point over here because the calculator won't find anything. We have to guide it a little bit towards what we're looking for. So where it says first curve, it's got the logarithmic function written up here. That's what I want to see. I know I've got the right curve selected, so I press enter. Then it says second curve, and that just shows the log of 6 divided by log of 7, so I know it's on the line. It's showing up in that same spot. Press enter again, because the guess doesn't matter. It calculates, and boom, our answer is a nice, pretty 6.6. Okay, that's all we need, okay? Calculator does have its merits. We just have to make sure we know how to use it. Now, for number 19, okay, we're gonna do the exact same process. Graph the left side, graph the right side, but we're gonna have a little more work to do on this one because of the way of where it's going to intersect. So if I do 5 to the x, parentheses, make sure you have parentheses here. I'll even write them here. X minus 2, close parentheses. There's the left side, and then the right side is 160. Okay, which again, just a straight number, so it's gonna be just another horizontal line. But this is gonna be through y is 160. So if I graph it, this graph only goes up to y equals 10. I can see it shoot up. There's my 5 to the n minus 2. That's no problem. What I can't see is this y equals 160. So I'm going to have to go into window, and I'm going to have to adjust it so I can actually see what it is I'm looking for. And the simplest way to do that would be to go down to y max and change it to 200. Okay, because 200 is bigger than 160, so I'll have a nice clear picture, be able to see above the intersecting point, below the intersecting point. This will probably be enough. I'm going to change this to like 50 for the scale. That way each tick mark isn't so close together. And then hit graph and see if that was enough. Oh, looks like we're good. And there's my point where they intersect, right there. Okay, so now that I've got that, and with the way these domains are going to work, this will be even easier. Second, calc. Option 5, intersect. First curve, we're good. I have an x and a y value, so I know I'm within the domain. Enter. Second curve, x and y value in the domain, we're good. Enter again. Give it a second to calculate. And there it is. 5.1534. Okay, round that last decimal place up because of the 8. I'm sure I don't have to explain that, but I've been burned before. Okay. And there's that one. Now, down here for number 20, it's the same process, except now we will have 2 separate curves. We won't just have one that's a horizontal line. 6 to the parentheses, n plus 2 or x plus 2. And then for the right side, it's just 9 to the x power. Graph. Let's see if we can see where these guys cross. There's 1. And there's the other one. Okay, so their intersection's probably going to be somewhere over here, assuming that they do intersect. So we'll do second calc 5. As long as it's on screen, we're good. So good for the second curve, good for the guess. And let's see if they cross. Fingers crossed, no pun intended. Yay, we did it. Okay, so they actually intersect way up here somewhere. And luckily enough, the calculator was able to figure that out. Now, take a moment to look at this. By the time we get to 8.8 on the x-axis, these things are already up to, what, 271 million, right? Exponential, they get real big real fast. Sometimes really gets hard to see where they intersect. Luckily, the calculator was able to find this without us zooming out that far. So we are looking at 8.8380. That's 4 decimal places. Okay? Now, here's where we're really going to have to think, is the inequalities. Okay? Calculator's going to find the intersecting point, no problem, as we've seen in these last 3 examples, but then actually figuring out where that's going to occur, is going to be less than or greater than, that's where this gets tricky. So, 7 to the parentheses, 5x minus 3, close parentheses, and then 80 for the other one, another horizontal line. Graph it. We'll keep that window the same because we still should be able to see it. Shoots up real fast, but again, doesn't matter how it looks as long as we can see that point right there where they cross, because that x value is our solution. Second calc, intersect, enter, enter, enter. And there it is, okay? So we have 1.0504, but we then have to figure out, is it going to be x is less than that or x is greater than that? Now, on the previous problems, I should have written x equals 6.6, x equals, or actually n equals for that one. Good, now it's sloppy, just like real class. And then n equals there. But now I got to figure out, okay, is x going to be less than this or greater than that? And my gut says less than, but let's check for sure, because if this is my point of intersection, okay, I got to look at it. Do I need all the points to the left of that or to the right of that? And you have to use your imagination a little bit, because this looks like it's going straight up, but we know it's not going straight up. It's just going up very quickly, so quickly that the pixels can't delineate. So I have to imagine, okay, this curve actually starts somewhere over here, right? That's what the shape of the exponential graph makes. Starts low on the left and shoots up, or goes the opposite direction. But this one, you can kind of look and see, okay, yeah, this one's definitely shooting up from the left. So I need to have all the x values to the left, which is my key that this is going to stay as x is less than 1.0504, okay? You know, your natural guess is probably going to be close enough on the right of these, but if we're going to use the calculator, we have to make sure we're using it correctly. If we're using the graph, we have to make sure we know what we're talking about, okay? Okay, now, this next one, this one does involve some algebra. There's no getting around it. You have to do change of base formula, all right? It says express log base 25 of 15 in terms of common logarithms. So I have to use change of base, but that's just log of the big number divided by log of the smaller number. Log of the argument, 15, divided by log of the base, 25. And that's it. Then it says approximate its value, calculator, right? We've been using change of base this whole sheet. Log 25 divided by, log of 15 divided by log 25. There it is, 0.8413. Okay, don't make this harder than it needs to be. Same thing with the next one, right? Suppose you deposit $1,500 in an account, 5.5% annual interest, compounded continuously. It even says use this formula, find the balance after 8 years, round to the nearest penny, 2 decimal points, okay? They give you the equation, just plug the stuff in. P is your principal, your initial amount, 1,500, times e to the, what's the rate as a decimal? 0.05, yeah, 0.055 times t after 8 years, there's t. Type it in the calculator, okay? Don't make this one harder than it needs to be. I know we like to get scared of word problems, but this one's just as straight up as 1,500. The e to the button is down here above natural log, right? So just second e to the 0.055 times 8. Close your parentheses around it. Oops, sorry. Okay, check that again. 1,500 e to the 0.055 times 8. Close the parentheses. And after 8 years, we expect the balance to be about $2,329.06. $2,329.06. And there it is. Okay. Now, again, we're down here, number 25. Okay, find the following, round if necessary. Could we do it algebraically? Yeah, but that's the other video. We're just graphing them all. So go to y equals natural log x minus 3 and 2. Just see where those two things intersect, right? Where does that natural log of x minus 3 cross? The line equals y equals 2. Graph it. Oops, we won't need that. Let's go back to zoom standard. And there's that, and there's that. Looks like I can see the intersection. So second calc, 5. Now same thing, we have to move that cursor over until I get into the domain. Once that cursor pops up and I start seeing y values, I know I'm good. Press enter again, press enter one more time, and right around 8 or so, I hope. Oh, okay, good. I'm glad this happened, actually, because it tells you no sign change. Does that mean no solution? Does that mean wrong answer? No, it probably means the cross where the sign changes from positive to negative. In other words, where the two lines intersect. That's how the calculator thinks about it. It happens off screen. So we need to go to the window, and if we look at the graph, we couldn't quite tell if they were crossing in this area. It looks like they're getting really close, but we have to see where they actually cross. Well, we just need to see further to the right. So now I make my x max 20, right? Just go further. And sure enough, now we can definitely see where they cross, right? So second calc, option 5. Oh, perfect. Enter, enter, enter. And sure enough, yep, it was just outside our window, right? 10.3891 comes out to be your answer, okay? 10.3891. All right, easy peasy. Next one. Oops. Clear. Clear. Graph the left side, graph the right side, see where the left side is above the right side, okay? Now, second e to the negative 4x, close parentheses, and 49. Now again, horizontal line, just a number, through 49, you're gonna have to adjust your window. So if I know that I have a line going right through 49, a horizontal line, let's jump that y max up to, say, 60, and we'll go by 5s for our scale so we don't get too crowded, okay? Tick it up and see what it looks like. Okay, there's our graph, okay? And this is interesting. We haven't seen too many of these, but now the logarithms are falling, or sorry, the exponent is falling, okay? So it's getting really close to 0 going to the right, but most importantly, I can see where they intersect right here. So second calc 5, first curve, good, second curve, good, enter again, give it a few seconds, and boom, there's your answer. Negative 0.972, okay, technically that'd be 30, because, yeah, the 5 would round that up, which would round that up. You guys remember elementary. And then finally, the last bit, okay? Calculator or no calculator, you have to do this part by hand because they just want you to write it as a single logarithm. Back it up. Don't you guys wish I knew how to use video editing? I forgot to finish this one, okay? Is it x is greater than that number or less than that number? So look at it again. Am I looking for the numbers to the right of that point or to the left of that point? And I want it to be, like, if we think about, okay, here's x, I was originally looking for all the points that were greater than 49. So do I need all the points that are to the left, x is less than negative 0.97, or to the right, greater than negative 0.97? And the answer is left, okay? Less than or equal to. I want to find all the points where this curve, which is this line, this curve, are greater than or equal to 49. Are they above that line y equals 49? And that's all up here, which is going to continue as I move further left. And so that's where I have the x is less than or equal to negative 0.930, because that's what's going to make that the case, okay? That's what's going to make that true, is this value and all the values to the left of that would have it such that this original is greater than 49. Excuse me. This is one of those things where if we're doing it algebraically, our regular rules for solving inequalities would just take care of it. We wouldn't have a problem. This is what we're looking at. Okay. Last problem for real this time. Single logarithm. Okay. We have to go back to those rules from section 7.5, right? I've got a log plus another log with the same base. So what do I do with the arguments? I multiply them. So I get natural log, the base stays the same, of x times 5, which is just 5x. And that's minus 3 times the natural log of y. Now, this 3 times the natural log of y, that I know can become an exponent. So if I move this over here, I get natural log of 5x, that stays, minus natural log of y to the third power. And what's nice about this one is it doesn't, I don't have to worry about like changing the numbers or anything. It just y cubed. I can't do anything with that. 5x, can't do anything with that. So I come to this, log minus another log with the same base. I divide the two arguments, natural log of 5x over y cubed. And that ends up being my final answer. Okay. And that is our video on how to solve this back part of the take-home quiz using your calculator, okay? If you'd like to see the algebraic version, click over to that and tell your friends to watch this because, like I said in class, you better watch it. I want to see lots of views on this, at least 15 or so I know everybody took the time that I'm taking to get this done. So thank you for watching. Tell your friends, and we'll see you on Monday.